Hi everyone. In this video we'll be talking about sliding window concept in Spark Streaming. So in the last video we talked about tumbling window. So if you missed that video, please have a look at that. So what we are going to discuss in this video is we'll talk about what is sliding window, what exactly is the use of sliding window, and then we will see an example for the sliding window. As we discussed that the streaming is kind of an unbounded, right? So we do windowed aggregations or windowed computations on the input data. So from time interval A and B, we are trying to find the number of sales or the number of users that are coming on the website, etc., etc. So sliding window is different from tumbling window in the sense that the windows can overlap. This is the first characteristic. Here in this example you can see, so there is a time interval of 12, 12:05, 12:10, 12:15, 12:20, right? So you can see this window is of 10 minutes from here to here, and then there is sliding window of 5 minutes, which means that the original time window is of 10 minutes, but the time window also slides 5 minutes. So what can be the intervals that can be prepared from this one? So first will be 12 to 12:10 because it's a 10-minute window, then slide by 5 minutes. I just slided by 5 minutes, I came here. Then from 12:05 take 10 minutes, this one. So from 12:05 to 12:10, what will be the time interval? It will be from 12:05 to 12:15, right? This is another window. Now again slide by 5 minutes, I came to 12:10. Then again take the 10-minute interval. So from 12:10 to 12:20. So as you can understand, the original time window is of 10 minutes, but we are sliding by 5 minutes. So this is called sliding window concept. You must have observed that any input that is coming in can fall in multiple windows. For example, the first event here, this one, the event timestamp is 12:07. Now if you have a look at here, 12:07 falls between 12 and 12:10, right? But it also falls between 12:05 and 12:15, isn't it? So 12:07 is between 12 and 12:10 and between 12:05 and 12:15, right? So this event can fall in multiple window. So that's the second characteristic of sliding window. Now why sliding window is used? So sliding window is used to compute aggregate statistics over a rolling time period. So in streaming systems, if you understand this particular sliding window is of 5 minutes, so we want to compute, let's say, count of this word that is coming in. Let's say this event is coming at 12:07, so we want to compute the count between 12 and 12:10, but we also want to count the compute between 12:05 and 12:15. So although this particular event will overlap, but that's okay, we want the count, so we use sliding window. If our use case had been the separate windows count, then we would have to use tumbling window concept, because there the windows don't overlap. Fair enough. Now let's have a look at this example. So this event, right, 12:07 is falling between 12 and 12:10 and also 12:05 to 12:15, which means if you want to count how many times dog came, so here it is, from 12 to 12:10 dog is 1, and then from 12:05 to 12:15 dog is 1. So there are two windows, this one and this one. So there are two windows for this sliding window concept for this event, right? For owl also 12:08, 12:08 is falling between 12 and 12:10, but it also falls between 12:05 and 12:15. So that's why you can see this event, this and this second and third event. So 12:05 to 12:15 owl is 1, and then 12 to 12:10 all is 1, so the count is 1. So there are four different windows and their respective counts for the two events, but it was not the case for the tumbling window because tumbling window was non-overlapping. Now let's consider the next event, 12:14. So where does the 12:14 fall? 12:14 falls between 12:05 and 12:15. So let's see if there is that event. Dog is also here, 12:10 to 12:20. Yes, it also falls between 12:10 and 12:20. Let's write it here. All right. So that is why the count is 1. Don't worry about this count. This count is 2 because it actually there is another dog event that came at 12:08, and 12:08 falls between 12 and 12:10, so that is why the count is 2. So now you must have understood how it is computing the state information. So previous state is stored, and whenever it receives the the same event, then it actually updates the count. All right, which we have already seen previously. Similarly, for the next event, cat cat falls between 12 and 12:10, right? So let's see if there is any record here between 12 and 12:10. 12 to 12:10, cat is 1. All right. Let's see if 12:09 is falling between any other window. So if you see here, so 12:05 to 12:15, this particular window also is for the cat, this one. But the count is 2. Why? Because there is another cat event at 12:14. Now 12:14 also falls between 12:05 and 12:15. So that is why the count is 2, because it will receive the event after this one and it will update the count. So now again dog was updated here already 2, and then all is 12:13. So 12:13 falls between 12:10 and 12:20. So let's see if it is there. All. So 12:10 and 12:20 all is there. Now another 12:05 to 12:15. Obviously this falls between 12:05 to 12:15. So it is 2. Why? Because there is another event, this one. It also falls between 12:05 to 12:15, this one. So the count is 2. So this is a little tricky than the tumbling window, because a particular event can fall in multiple windows. So just try to go through this example by yourself and try to understand how this windows are getting calculated. So hopefully you got some idea about the sliding window concept. Now we'll have a look at the program. So we have created a Spark session, then we have given some configuration related to Kafka. We are reading the Kafka topic called Windows demo, and then we are not reading the key, we just want the value. We are printing the schema to see what is the schema of the original data frame that is getting created when we are reading the Kafka source. So as you can see, I am passing this particular record as a comma separated. So we want to extract the timestamp, which is the first record, and the second one is the actual word. So here this particular UDF, the user defined function, is returning after splitting the line from with the delimiter as comma, and whatever index you will pass, it will return that index value. So we are creating another data frame from the original data frame, and we are creating another column called timestamp with the timestamp value as this one and the word value as this one. The second column is word, which is the value after comma. We don't want the value column because we just want timestamp and word, so we are dropping the value column because value column is there in the original data frame. Now we are also printing the schema of the data frame that we have created from the original data frame. Finally, what we are going to do is we are going to group by, and we are creating the window of 10 minutes, and then there is a sliding window of 5 minutes. So this is how we can actually create a sliding window. We are also doing a count operation. So group by the window, and then we want the count. So finally we are creating a streaming query, and we are writing the output to the console in the update mode. So if you remember the update mode, it will remember the state from the past, and it can update the state accordingly if it actually sees the record the next time. We are using truncate as false as we don't want to truncate the output, and we have also used a checkpoint location. Finally we are starting the streaming query, and we are waiting the query to finish either by an exception or the query gets stopped by query dot stop. But since we are not doing a query dot stop, so we are not using this stop function, so it will just keep on running until any exception is occurred. So I have started this program. Let's put on some data in the Kafka producer. I'm going to copy these values and I'm going to put it here. Now we are going to see the output. As you can see here, for this particular two events, there are four windows that are calculated, just like I explained in the example. And if you put all these events the next micro batch, then what will happen? Then the next set of windows will be calculated and the output is same as what I have shown in the example. So what I will suggest is go through this code, try to run it and set up the local Kafka. It's very easy. I have also created a GitHub project where you can follow the steps and create your local Kafka cluster, put some data in it and experiment with it. So I hope you understand the sliding window concept in Spark structured streaming. So that's it for this video. See you in the next video. Happy learning.